Kore.ai team. We have Tim and Michael. And Michael, if you gentlemen are ready to go, you have the ability to share and run your presentation, and we are going to start the timer now.
Thank you, Carolyn, and all of Team Tech Grow for the coordination and making this event successful. My name is Michael White. I am our AI team leader for this event. I'm the contracts manager at Metris Global. I'd like to introduce our ISD SME, which is Mr. Tim Haas, retired Coast Guard captain, director of human performance at Metris Global. And for our SME for the AI engineering part is Mr. Michael Piotrowski, Senior Innovation Solutions Architect Engineer at Kore.ai. Please take it away, Michael.
Okay, thank you very much for that, Michael. I'd like to talk a little bit about the scope of the problem and how that drove our approach. And so in the upper left-hand corner, we have the occupational standards and some data from NAVPERS 18068 Foxtrot. And you can see the large number of job titles and various duties and task definitions in this document. And we looked at this challenge as building a proof of concept to show how we could efficiently generate all of the ADDI documents that would be needed for this. And we had 5 different documents from the GFI. We had 3 worksheets that we're going to focus on here: task analysis, learning analysis, and media selection. And we also had a couple of other documents, the IPRD and the IMRD. And if you take a look at how you multiply together the number of different tasks that you have and all of the different artifacts, 170 columns across these 3 worksheets, for example. And if you make some other assumptions, like how often do you have to generate a complete set of PADM artifacts for all of these different job titles and ratings, and make an assumption about how much reuse you could get, you come up with a pretty large number. So here we're showing about 7 million different cells to be generated. And so how do you get at that? And so our team built a AI maturity model to look at different levels that you might approach. And we wanted to target level 3 here, which basically means we need to create a unique prompt for each column, rather than having a unique prompt, say, for every different job task or job duty, okay? And so this would mean generating 170 general purpose, general use prompts, as opposed to maybe tens of thousands of different prompts that you might need to do manually. And so the task really becomes, how do we target and how do we prove that we can get to level 3? And our solution approach was to use a prompt generation language so that we could dynamically generate general purpose prompts with enough variability to hit the target here. And we've done enough of this. We've actually generated quite a fair amount of data here, and we are confident that we can get to level 3 with a high probability of success. And with that, I'd like to turn over to my colleague Tim to go over some more detail about the background.
Yeah, so our interpretation of the problem statement, very, very similar to what Mary Driscoll said at the beginning during the kickoff. The problem is volume. And I think Mike's slide just there with 7.2 million potential cells to be interfaced with kind of shows that. But really, it's about alignment with RRL, and that's what I'm going to cover in the next few slides. There are these RRL lines of effort. We are looking at a proof of concept, and this particular slide was from the kickoff meeting way back in October, which seems like a long time ago now. It provides that kind of bird's eye view of PADM, and really, as we animate this, you're going to see that we're focusing on the analysis stage, right? It is those analyses that are going to drive this the evolutionary initiatives in RRL. It's also going to drive the integrated content development and the eventual LMS delivery using things like XAPI. So it's, you start with analysis. It's the great HPT model. The next slide again shows where the AI integration is going to incorporate into RRL. Anybody that's familiar with RRL, which I'm sure it was, Lieutenant Commander and the other folks there that have been living and breathing this stuff know this slide. It is in their vision statement. And again, as we animate, you're going to see where this challenge lands in the greater RRL landscape with that focus on analysis to drive the evolutionary initiatives. Again, a focus on analysis to assist in the integration and making content more relevant. We've got a few more animations here. Yep. And one more. And there we go. And then again, that focus on analysis for the LMS delivery and using AXPI. So really makes sense, right? The challenge was definitely geared to align us with RRL. We just understand that very implicitly as part of the problem statement. And with that, I'm going to turn it back over to Mike to talk about why we used a virtual assistant.
Thank you, Tim. So the virtual assistant's role is to bridge the gap between the technology, the Gen AI and the large language model, and help them do the PADI-M process. So the roles like an ISD analyst, the Navy subject matter experts for the rating and question, and maybe assisted by a Gen AI specialist there in the background, leverage a virtual assistant to generate all of these artifacts in as automated and as efficient way as possible. And we're able to improve team collaboration, help out with knowledge transfer, and really bring to light this PGL process to generate the necessary inputs to efficiently get the outputs as quickly as possible that the PADI-M process requires, okay? And now I'd like to switch gears just a little bit and talk about AI large language models, and we evaluated a fair number of these. We looked at 12 large language models in particular, created some of our own benchmarks, and used some other public benchmarks and other available data. And we made a selection to use ChatGPT-4 Turbo. The version was just released on November 6th. And we did this because it scored the highest in the areas that we thought were most important to us. We thought that the Gen AI capabilities were the most important, and that's where it did very, very well. But some of the other models did well in certain other areas. For instance, Azure OpenAI GPT-4 scored the best in our journeyman electrician tests and the other subject matter expert tests that we gave it. And then finally, if you were going to be doing classified ratings as opposed to unclassified ratings in this challenge, you might want to use a model that you could host privately. And so an example of that would be Meta's Llama 2, which you can download and host, and we also evaluated as well. And just to summarize, this is a very complicated task, and considerably more effort would be placed into picking the best LLM in an actual project. Okay, so how do we then get from the large language model itself and couple the virtual agent and put all that together to generating a prompt? And this is really a microscopic view of the prompt generation process. And we break the prompt generation process into a part that provides overall context. And this would be independent of the actual cell. Okay, it would be across all the projects. So we could bring in things like the rating description and things like that to give the context. Then the actual instructions that we're going to give to the LLM would be very dependent on the actual column in question. And this is where we use PGL so that we can get at all of this metadata from the occupational standards and from other documents we ingest, and also from the worksheets themselves with a large number of information in the column headings as well that we would bring to bear in the PGL. And this is what the process looks like in our solution. So we start out with the occupational standards. We bring all of that rating metadata to make it available. We have a number of other baseline documents that we use, and we bring in the metadata from the worksheets as well. And then we pair the virtual agent with our large language model, in this case, ChatGPT-4, and we make the virtual agent available to the subject matter experts that are working on this, as well as during the review process. And the users of the bot are able to send commands to the RRL virtual assistant to make it generate the outputs, and they can review intermediate outputs, and they can create the actual artifacts like the worksheets and the IPRDs that are required here. And they can say things like create a new project or edit the prompt generator, the PGL. And at the end of the day, they're going to have a set of artifacts, including the worksheets that are needed for the process. Okay. And this blows up a little bit about what the prompt generation process looks like. You can see the column independent background information or context that's generated, as well as the specific details that are brought to life with the PGL language for the for the column in question. And this is what it all looks like at the end of the day. So here is a prompt that's being generated to look at whether the first, whether this job would be performed at the first sea tour. And you see that we have a prompt and then a nice detailed answer here. No is a short answer, and then a quick explanation as to why the LLM picked that particular answer. Okay, I'm going to turn back over now to Tim to look at some of our findings in a little more detail.
Yeah, and so we spent about the first 10 minutes of our presentation talking about the construct and solution that Mike P really put together for us, and then as we started to consolidate the findings, we obviously took the 3 data sets, which are one axis on this table, and inserted those data sets into the workbooks, right? As I'm sure all the teams did. The first data set, we were able to get a lot of practice, and it gave us some optimism because we were able to evaluate each column in the workbook and apply automation and AI responses to, I would say, a majority of those columns. We are in the follow-on data sets, currently up to 1,521 cell responses and counting, where the task analysis and learning analysis have had cells populated by the virtual agent that we use. And we're going to actually share the exact percentages and more details in private at the Q&A session. And very much like they showed the results kind of being populated, we have all of that working still behind the scenes, and we're going to share that more at the Q&A. But for the next slide, I'd like to just, for the sake of time, talk a little bit about the questions for this pitch event. And one was the requirements for implementation. We really feel like there are minimal ones in terms of software and hardware dependencies. We shared the ones related to non-class or class requirements to use the Kore.ai application or the virtual agent. We've kind of talked about a lot of the data needed to run in the data flow slide. And when it comes to training of the ISDs and the analysts, we really feel like this will be fairly minimal, less than 40 hours, all available on the Kore.ai Academy site, where they have webinars that'll help people understand AI and help ISDs, get a deeper dive into PGL. The next slide really just gives you a graphic representation of the on-class or class trim versions of what the solution might look like. Very similar to what's already been talked about. Depending on the classification level of the rating, we may want to put it behind the Navy firewall, or we feel like many ratings could easily be dealt with in a non-classified cloud version. Next slide is going to talk a little bit about the test methods and result verification. For the sake of time, I think we'll just kind of leave it to these bullets, let you read those. One thing I do want to highlight is the team was very focused on the bias aspect and also the guidance that came out in the executive order in late October. And we were able to, in researching that, kind of align closely with the TEVV mantra that's in the federally endorsed AI creation process from the National Institute of Standards and Technology. And so this AI risk framework, again, was very easy for us to relate to. It focused on bias, the systemic biases, the statistical and computational biases, and the human biases were all identified in the executive order, and the team was very, very attuned to making sure we try to address those as we build out. And so with that, we want to get you a demo of the bot, and Mike's going to go ahead and take that over.
All right, thanks for that, Tim. Let me just bring up the our virtual agent, and I want to make sure that you guys can see this right now. So let me share this particular one. And so we have a virtual agent right here that I'm opening right now. It's the RRL ISD advisor. And you could set up a new project here. We have a methodology to bring in the various artifacts needed for PADI-M. I want to right now, though, dive into the project that we did set up. We did set up a project for the construction electrician. I'm going to open that up right now and take a look at what we've done for that rating. Okay. And right here, we have the various phases of the PADI-M process, and we're focused on analysis. And we get into analysis, and there's several different artifacts we can get at. Okay, we can build some of these prompt things, and we have task analysis and learning analysis here, and we have media selection over there on the right. I'm going to pick task analysis, and I'm going to go take a look at some of the things that we've already done. So we're not going to be making any updates. All of these updates, really the artifacts are stored in a database here, okay? And I want to take a look at column E over here in the task analysis worksheet, and we use the additional notes to capture the step-by-step procedure to do an actual task. And we're going to focus on data set 3 here, power generation, and take a look at the various duties for that. Excuse me. And we're going to look at the calculate power generation load requirements task and get into that right now. And let's take a look at the actual prompt that was used in the output. Okay, so this is the prompt that was generated with the process that we used, including PGL. Okay, and we can make this look a little bit bigger if we want. And then we also have the output of this. And here we have the step-by-step process that was generated for doing calculation of power generation. And we followed the tree of thought methodology there. And let me just close this up here. And then one of the things that I can do is this is conversational. So I could type in something like CPGL. And we can actually look at the PGL language that we have right here. And this is how PGL is used to generate the column specific things here. And this is a tree of thought method and an explanation for what the LLM is expected to output. Okay. And with that, I'm going to wrap up the demonstration and pass back over to Tim right now. Okay.
So, yeah, thank you, Mike. Our user story is really just centered around a Navy ISD using the name Alex, and you can consider Alex as a veteran that turned into a 1750 series GS and has been working on getting relevant content for several ratings. These are some of Alex's goals and pain points. And the one thing I'll tell you is Alex is passionate about ensuring training decisions are data-driven versus anecdotal, right? There's a solution here that's proposed. And then really the story on the next slide just gets into, the little bit of reskilling he might need, the issue of updating the CE rating, which again is what the challenge was focused on. And then the true gist of it is the collaboration with the virtual agent, and that human virtual agent collaboration is really the key to this whole user story. We do provide a quick example again of that testing, eval, verification, and validation that takes place. And in this instance, it's a lot more than Homer Simpson, repetitively pushing a button at a nuclear power plant, right? There has to be that human verification. On this one, we do a deep dive into the some of the frequency data so that the train, no train decision that's been output is, again, tested and verified. So, I won't belabor the whole story, but when it comes down to it, there is a tremendous value proposition that comes out of it. That's on the next slide. And that value proposition is talking about time efficiency, accuracy, collaboration, adaptability, and then all of the tools that the Kore.ai has in its suite. So we're talking about enhancing Alex's ability not only to collaborate with SMEs, an ISD team, but also with the virtual assistant. And what that does, it provides a greater access to the highly ranked tools that Kore.ai has, but it provides a greater level of acceleration to do these analyses. The next slide is just a graphical depiction of how that team works together. And I can tell you, Mike and I are proof that an ISD and an AI engineer can coexist and find great synergy. It's been an awesome time working with him. And then the next slide just overviews our implementation. we've already covered a lot of this already in the presentation. The RAG is the one thing I would highlight, as well as being able to capitalize on a lot of the rating info that are in the NAVPERS occupational standards publication. Potential barriers, much like our predecessors, we feel like there are some logical ones. They all can be mitigated. And, we really feel like when it comes to humans driving this process, there's a tremendous amount of collaboration, not only in change management, but in actually leveraging the technology. And so to wrap up, because I know our time's getting limited.
We actually are done, Tim. So your time is up. So thank you so much, Metris Global Kore.ai team. Great job. Another great job. I don't have any judges here. So